Good morning, and welcome to You Math and Me. I'm George Randall, and today we're going to talk about, again, please excuse my dear Aunt Sally, which is order of operations. And in particular, we're going to talk about exponents. Exponents. Again, as you see here, P represents parentheses, E exponents, M multiplication, D division, A addition, subtraction from left to right, whichever comes first. Exponents. And we write 6 to the 4th power. In this case, the 6 is what we call a base, or the factor that's going to be repeated, in this case, 1, 2, 3, 4 times. And what that means is we're going to multiply 6 to the 4th power. 6 times 6, which equals 36. 36 times 6, which equals 216. And 6 times 216, which equals 1,296. That is 6 to the 4th power. Okay. Now, I write this up that way because you're going to see things when we talk about some properties of exponents. But for right now, we're going to look at this particular item over here, which is 3 to the 5th power. Okay? And again, as I've written, that means the base is 3, and we're going to repeat 3 5 times. 3 times 3, as you can see down here, 3 to the 2nd power is 9. 3 times 3 times 3, which is 3 to the 3rd power, 27. And 3 times 3 times 3 times 3, which is 3 to the 4th power, 81. And then, of course, 3 to the 5th power, which totals 243. Now, we have a pattern here that's taking place. Again, we start out with 3 times 3, 9. We multiply that times 3. In other words, 9 times 3 is 27, which is 3 to the 3rd power. And then we take 3 times 3 times 3 times 3, which is 3 to the 4th power, which is multiplying 27 times 3 to get 81, and then 3 times 81 to get 243. So we start here because we want to also talk about going in the opposite direction, or 3 to the 1st power. Now, what mathematicians agreed that if we square 3, okay, that's 9. And if we go 3 to the 1st power, that's 3 times 1, okay? However, they agreed that 3 to the 0 power equals 1. It could be 4 to the 0 power, 5 to the 0 power. It would still equal 1, okay? But of course, we have negative numbers where we will write, in this case, 3 to minus 1. Now, mathematicians, again, look at this, and we cannot express an exponent as a negative, so we have to look at some other things. And so first, I'm going to look at 3 to the negative 2, and the way we rewrite that is 1 over 3 times 3, which is, in this case, 1 over 9. Don't want to express an exponent in a negative power. So now let's look at this. As we go in a decreasing power, when we went upward, the values increased. We started with 243, and we're going to go down to 3 to the 4th power. Actually, 3 to the 4th power, is 1/3 of 243. And we'll do the quick calculation. Because what are we going to do here? We're going to multiply a whole number, 243, times 1/3. That's what that pattern says do. 243 times 1/3. In this case, and that's really this, and we can do cross multiplication. 3 goes into itself once. 3 goes into 24, 8. And 3 goes into 1, 81. And 81 over 1. And that's 3 to the 4th power. As we continue to decrease, it says here that 3 to the 3rd power is 27, which is 1/3 of 81. Again, 81 times 1/3, and cross multiplication, 3 goes into itself once, and 3 goes into 81 2 times. 6 subtract, you got 21, and that's 27. In other words, let's do this over here so you can really see it. So in this case, 27 over 1. And we're now down to here. So a pattern is working out here as we decrease, as we talk about the next step, which is 3 squared. 1/3 of 27 is 9. And if we go to 3 to the 1st power, 1/3 of 9 is 3. And of course, when we go 3 to the 0 power, it says 3 times 1/3. And that's 3 over 3, which equals 1. And that's why we say 3 to the 0 power equals 1. Okay. And the same thing would take place if we were looking at a different base. And now again we look at that 3 to the -2, rewritten is 1 over 3 times 3, which is 1/9. Or 3 to the -3 would equal 1 over 3 times 3 times 3, which would be, again, 3 times 3 is 9, times 3 is 1/27. Okay. All righty. So again, we've talked about a base, in this case 3, and the exponent 5 says that we have a factor 3 that's multiplied 1, 2, 3, 4, 5 times. And in this case, this equals 243. Now when we come back, we're going to look at some properties of multiplication of exponents. And again, before I go, you can reach me at gerandall22@gmail.com. I'll be right back. Thank you. Hello, 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 hello. Again, I'm George Randall, and welcome back to You Math and Me. And now we're going to look at some multiplication properties of exponents. And I use variables initially because, again, this A represents a base that is the same, okay? And we're going to multiply these particular items. And what it says, as we look at it, is that if we have the same base, okay, in this case A, and we're multiplying a to the n times a to the m, where the a's are not 0, then the answer would be a to the n plus m, okay? So now with a numeric, with numbers, we have 4 to the third power, or 4 cubed, times 4 to the 7th power. And what you do is repeat the base and add the two exponents, and you'd have an answer of 4 to the 10th power. And of course, that would mean that we multiply 4 times 4 times 4. That's 5 fours. And then 5 more fours. And that would be some astronomical number, which I'm not going to do right here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 to the 10th power. Okay? So that's multiplication with the base being the same. Now, let me just flip over and look at a situation where we have 4x to the third power in parentheses to the second power. Now what does that look like? Again, we got all of this, and now we got to take this and square, and this and square. Okay? And in the first concept, remember, we added. So, let's separate. We got 4 squared times, because that, whenever we write a numeric or an alpha, that means 4 times a, okay? Times 3 to the second. Okay, so what does that mean? On this portion, first we have 4 times 4 times x to the 5th power, because remember we add. Okay? So the final answer would be equals 16 x to the 5th power. I apologize. This should be, it should be just what it is, multiply. Made a mistake. Error. Don't add. This is different, 2 different bases. So this is 6, and that's 6. Okay? All righty. So as we look at these particular properties, they're going to be somewhat confusing because remember, when we started out, one of the things that I talked about was having 4 to the negative 2. Rewritten because they don't want negative exponents, that has to be 1 over which equals 1 1/16. Okay? Okay. Now today we introduced just some basic properties of multiplication of exponents. And we'll do one more, and this has to do with division, where we have to simplify 4 to the second over 4 to the fourth power. And in this case, we have similar bases, and the rule says that you subtract, in this case, or actually, let's look at it this way so that you can really see it. I've rewritten that's the base 4 expressed 4 times 4. That's the base to the fourth power, 4 times 4 times 4 times 4. And in subtraction, when we do this, or division with whole numbers, let's say we had that. Let's rewrite this 6 right? Okay. And we do this. But in this case, we'd be left with 1 over 16. And in this case, let's do this the opposite way. 2 over 6, which should be 1/3, right? So what took place here would be the same thing as doing this. 2 subtract 4 for these would be a -2, and you'd have 4 to the -2 power. But we can't leave it like that. We've got to take it and equal 1, which is 1, which equals 1 to the 16th. Exponents. A little bit different in what we've been doing with our basic division of fractions and basic division. There's a lot more rules involved in using these exponents. So remember, we've got a base, and this is the factor that's repeated, in this case, 4 times. And we multiply 36, then 36, and then last but not least, I believe it's 216. And then that equals 1,296. Sometimes the memory works. Okay? So again, if by chance you need to reach me, I can be reached at gerandall22@gmail.com. I want to thank you. Again, I'm George Randall with You, Math, and Me, and we'll see you next time.